magic, where learning physics is magical. In the previous episode, we actually used physical conservation of moments, and you can see how moments is used. We actually have 3 moments equated inside the question. That's why you notice I didn't work to any moments question. I went directly to the conservation of moments. So question 2, exactly similar. The picture chosen to be quite nasty, but if you understand the concept of moments where you need a force and perpendicular distance, this sort of question is actually quite easy to answer. You actually got an L-shaped object, and you got forces here, here, and here. A rigid L-shaped level arm is pivoted at point P, so this is your pivot here. 3 forces act on the level arm as shown. 3 forces, 1, 2, 3. What is the magnitude of the resultant moment of these forces about point P? So we have, let's call it A, force A, B, and C. In this case, notice this object is actually moving. How do you know it's moving? Because it mentions resultant moment. That means this is not a stationary object yet. It actually either move here or here. So that is our job, to find out whether it moves. If not, then it must be stationary. So, first of all, we begin with changing a complex structure into a simpler question. Force A. So, all you need to do is draw a pivot. Your force A is this direction. So, if it was me, you can actually extend it, and you notice you already have your first diagram, which is force A and distance A. In this case, your force A is 5 Newton, and the distance apart from the pivot, careful, you must have the perpendicular distance. You got 4 meters total, and this one is 2 meters. Therefore, from the pivot, XA is just 2 meters. Okay, so I hope you guys can see the explanation for part A. Part B is a force here. So pivot is here. Extend the force. Force B is equal to 10 newtons. You're looking for perpendicular distance. In this case, it is XB, is 2 meters. C over here, and we're looking for this distance here. If you look at the picture, this time is clearly shown. Draw your pivot. FC is equal to 50 newtons, and the distance here is just 3 meters. From a complicated diagram, you are able to break it down into smaller parts, and then you use using principle of conservation of moments. Sigma anti-clockwise moments equal to sigma clockwise moments. Notice I always put direction, so that at least I know I'm putting it in the correct location. Clockwise this and anti-clockwise. Notice I always put this. So you might as well do it as well. So we go to A. A is clockwise and anti-clockwise. Pivot doesn't move. So force move like this. So this is anti-clockwise. So we have 5 newtons times by 2 meters. Then we go to B. Again, pivot doesn't move, force direction, so if we actually turn it, it's actually moving anti-clockwise. So we got plus 10 newtons, 2 meters. Remember again, this is summation symbol, means we add it up. Then, let's check it out. This part here is 50 newtons, 3 meters. And then you turn it clockwise. So 15 newtons, 3 meters. So 5 times 2 is 10 Newton meter. 2 times 10 is 20 Newton meter. 15 and 3 is 45 Newton meter. I'm going to calculate with me, so there's a mistake. Just drawing something back. Then you notice it's 30 Newton meter is not equal to 45 Newton meter. Therefore, using this equation, you notice it is definitely not stationary. Remember again, what is principle of conservation of moments used to show stationary objects. In this case, it's not equal, it means it's not stationary. So how would you then do this question? Quite easy. You can either use that method and put it in the right order because it's quite obvious that the final answer will be 15 Newton meter, and there is more positive, so therefore the final one, you can say the final one, the resultant will just be a moment of 15 Newton meter in the clockwise direction. Okay. If not, if you want to do it in a form equation, quite easy. What you can do is this: resultant moment, just like we do resultant force with the FA, you must choose direction. So here you choose direction. Let's say we didn't know what the direction is. Let's just say we take the resultant moment, the final moment, will be in the anti-clockwise moment. So you choose the direction to be positive and anti-clockwise moment. So what happens in this part would be you have your 5 Newton, 2 meters, positive, plus your 10 newtons, 2 meters, positive. Your clockwise moments, which is opposite in direction, that will be minus 15 newtons, 3 meters. And if you do the calculations, you'll probably give you something like minus 15 newtons. Again, don't worry you choose the right direction or not. The science will tell you whether it's the right direction. Since you already chosen and shown your question that it is anti-clockwise, like a negative, that means your final answer will be in the clockwise direction. So you can say resultant moment is 15 Newton meter in the clockwise direction. And then if you want, always draw clockwise direction to show them what you are talking about. I'm going to show you what happens when you choose one direction, because sometimes students worry that you must always pick the correct direction. No. Choosing direction means you just choose direction. Your calculations, the science will tell you which way is supposed to be. Okay? So don't worry about that. So I hope you understand this video.